Hi thinkers, welcome to the Cracking the Coding interview course on ThinkX Academy. In this video, we're going to start with a lead code problem, which is 206 lead code problem, which is to reverse a given linked list. So in this course, I'm going to cover a lot of lead code problems that are basically asked in a lot of coding interviews, and I will show you the whiteboarding skills that you need to actually pass the coding interviews or to clear the coding interviews. So in the technical round, how you will approach a given problem, right, and how to actually come up with certain solutions and how to ask questions with the interviewer. That's what you're going to learn in this course. So let's start with the easy level of this problem. So here we have a linked list data structure related problem. So the problem says that we are given a head of a singly linked list. So you can see here in this example, we have this linked list and we are given a head pointer to this linked list, right? So it says that we are given the head of the single linked list, we need to reverse the list and we need to return the reverse list, right? So this is the function that you're given and you need to implement this function, which actually returns the head reference to the reversed list, right? So this list node is actually the reference to the reverse list. So you can see here it returns the reverse list, right? So now you will have to ask the first question from the interviewer as to whether you can use a separate linked list data structure. So can you create a new linked list and can you just start pushing the elements from this last position and into a new linked list and return a reference to this list? So you can see here we can just create a stack data structure and we can push all these elements. So I can push 1, then 2, then 3, 4, 5 inside of the stack data structure, and I can just pop the elements from the stack data structure like 5, 4, 3, 2, 1, and I can place them or push them inside new linked list like this. So I will get a new linked list, something like this. But the interviewer will say that according to this problem, you are not allowed to create a new linked list, right? So the question itself says that it should be in place. So in place basically means that you will have to make sure that this given linked list, you need to change these references which are here and you need to convert it into this list and you have to return the reference of that list which starts from head position. So you can see that head was initially pointing to 1 and you need to reinitialize it to 5, and you also need to invert these arrows, right? These references or these next pointers, you need to actually reverse them, and that is something that you need to do, right? So there are two approaches to this problem. One is going to be a recursive approach and one is going to be an iterative approach. So in the recursive approach, we are going to simply go from the first position. We are going to make a function call from this first node and we will keep going to the next node. Once we reach here, we will backtrack and we will keep reassigning, keep inverting these references to the previous nodes, and we will be able to get this list will get reversed, right? So that's the recursive approach. In this tutorial, I'm going to cover the iterative approach as it is intuitive and very simple to understand, right? So always choose the approach that you find simple to implement in the coding interview and make sure that it is also optimized. So here in our case, recursive, iterative, both approaches have the same time complexity, right? So let's start with the iterative approach. So what is the idea that I'm going to use here is, so let's say we are given a linked list head and we have this linked list with elements 1, 2, 3, 4. So these are the 4 elements that we have. So what I'm going to do is I'm going to start with the first node, which is 1 in our case, and I will start with this node and I will make sure that the next of this node will be reassigned to the previous node, right? So I need to take care of two variables, which is previous node and current node. So let's say I'm at this node, I will mark it as a current node. So I will create a reference which will be initially pointing to the head position. So you can see head is pointing to 1. So our current is also pointing to 1. Now what I need to do is I need to reassign the next of this current. So current.next needs to reassign to the previous node, right? So I need to change this node. So I'm going to just erase this one. I need to change this node and make sure that this node points to our previous node, right? And you can see we do not have previous node as this is the first node. So we are going to create a previous reference which initially points to a null position. And what will happen is in the next iteration, I will move this current to the next node and I will move this previous to the current position, right? So it's very simple to understand because what I want to do is I want to do the same steps iteratively, right? So I need to move this current one step ahead. So now current will be pointing here and I will also position the previous to current, right? So now current will change to the previous is now going to point to the current position and I will perform the same step again, right? I'm going to again remove this link and I will again make sure that it points to our previous node. So you can see this is now the new previous node. So now the next of this is going to reassign to this one, right? I will keep doing that until and unless my current node is pointing to null, right? So if my current is pointing to null, I will halt and at that position previous will point to the last element. So I'm just going to return this previous value and we will be able to get the reversed list, which will have all the reversed arrows like this, right? So one thing that is a problem here, right, which is that, let's say I'm going to remove all these nodes and we are just going to consider this one. Let's say we have this first node, and now I try to remove the current dot next and point it to previous node. You will be able to see that I have no reference to this node, right? To this node, I have lost this reference because I reassigned it to the previous node. So in that case, how will we reassign current to this next node, right? So what I'm going to do is, before reassigning it to previous, I'm going to make sure that we create another reference, which will be a temporary reference, and temporary reference is going to point to this one, and this is actually current dot next, right? So what I'm trying to do here is, before I lose this link here, I am actually storing a reference to this next node, so I can reassign current to this next node, right? It is an important step, and if you don't do that, you will not be able to access this next nodes because of the assignment of this current dot next to the previous node, right? All right, so let's start with the coding part. First, I know that I need to create a list node, which is the previous node, and I will have to mark it as null. And similarly, I will have another node, which is the current node, and this current node is actually going to point to the head, right? So list node, I will say CUR, is going to be equal to the head node. Now what I need to do is simply I need to create a while loop which will go until and unless this current node is pointing to null. So I will write if current is not equal to null, right? Then I'm going to perform these steps, which is the reassignment. So what is the first step? The first step is to actually create a temporary pointer, right? So what I'm going to do is I will create a list node reference, which is actually going to be our temporary reference, and this temporary reference is it will be equal to current dot next, right? So I'm going to write current dot next here. So it holds the reference to the next position from the current, right? Now what I will do is I will have to make sure that I reassign current dot next to previous. So that's what I'm going to do here. I'm going to write current dot next will be equal to the previous node. So this is again a very simple step. And now what I will do is I will have to make sure that I do the reassignment. So now we have to change previous to the current node. So previous node will or the previous reference was initially pointing to null. Now it needs to point to the current position. And similarly, I need to reassign the current also to point to the next position, which is the temporary position. So I can just write current is equals to temp, right? So current will now point to the next position, which is the temp position, and I will end the while loop here. And we know that at the end of this while loop, the previous node is going to point to the last element. So I can just return that reference. So I can just return previous reference, and we will have the required list, which starts from the previous reference, which is the last node, and we have successfully inverted all these arrows, all these references, right? So that's how you need to show do a dry run, right? So once you have written the code, make sure if you're in an interview, you do the dry run. So you will have to just show how at each and every step the lines of code are working and how the things are going on. So you will have to explain that we will start from here. Temp is going to initially point to current is going to point here. We have previous, which is pointing to null here, right? And temp is actually going to point here, right? So you will have to do this dry run technique, and this is very important because in the coding interview, you will not be given a IDE or a playground. You will not be able to actually run this program and test these cases. So whenever you are given this, you will have to run the dry. You have to use the technique dry run. So you actually go line by line and you do it on the input that is given to you, right? So you can find whether you have made any mistake or not. Now let's start with the dry run. So it says, okay, we have temporary equals to current dot next. So temp is pointing here. Now we move to this line. It says current dot next equals to previous, right? So this is the current dot next. It will be reassigned to previous, and you know that previous was actually null. So 1 is actually now pointing to null, right? So I have 1 and it is now pointing to null. Now I do move to the next line, which is move previous as current. So now previous will be assigned here. And you know we have lost this link, but we have the temporary reference, so we can actually make sure in the third step we assign the current to this here. So current will move here. So we have current here, and similarly we are going to do this again and again, right? So now again this current dot next will point to the previous node, which is now 1. So now this will go here, right? So you can see that we have 2 here, which is pointing to null. sorry, it is pointing to 1 here because previous has changed, right? And again, temporary variable also gets reassigned because you can see that when while loop starts, it assigns the temp again as current dot next. So current dot next is here, so temp gets reassigned automatically, and we will again keep doing this again and again till we reach the last position. And at the last position, previous is going to point here because current is pointing here, right? So we can just return the previous pointer, which is the reverse list, right? So we have successfully done the reversing of this list and it is done in place, right? We're not creating a new linked list here. So that's all for this tutorial. We'll see you in the upcoming tutorials. Make sure to like this video if you have liked the way I approach and the way I actually teach the concepts, which will be very helpful to crack the technical rounds of the interviews of big companies like Amazon, Google. So that's all for this tutorial. Thanks for watching.